Friends, good morning, good afternoon, good evening, whichever time zone you are on. Um, it gives me great pleasure to welcome you all to this session on analytics and artificial intelligence by Kevin Simon. I would want to thank Kevin for making it today and for presenting this webinar. It's early morning for you, and we truly appreciate your presence today. Friends, this is one amongst the many sessions that we have been having during this sort of circuit breaker period that we are in at this point of time. And we appreciate your participation in these sessions and your contributions and questions too. We would encourage you to share more of your questions so that we can enjoy the clarifications from Kevin and take our thought process further on this area itself. Uh, with that brief introduction, I think Kevin's profile has already been shared with you all in the mailers, and he's the product lead analytics as CaseWare Idea Canada, and he's the key resource when it comes to this area of analytics and artificial intelligence. And I'm sure that he would be, you would enjoy his session on. With that brief introduction, may I hand over to Kevin? Kevin, thank you very
Uh,
much. And we are looking forward to your share.
okay, I believe I'm sharing my screen now, and hopefully you can hear me. If someone can confirm that, I'd appreciate it.
Yes.
Yes, Kevin, we can hear you.
Wonderful, thank you. As noted, thank you for that kind introduction. My name is Kevin Simon, and I'm the product lead for analytics for IDEA. I'm going to take you through today a short deck that introduces some of the concepts of analytics AI and what we're trying to do, and then we'll hop into a demo of the software so you can see it. So my background is not in audit, it is in product management and computer engineering. So I'm working with data sets, business intelligence, presenting ideas back, and how to use data to drive decisions. So this is a interesting fit, or a very good fit, with what IDEA and CaseWare wish to do with the audit of the future. So we think that in the future, the audit will become more of a data-driven engagement. So obviously data is a heavy component in financial statement audit now, but it's a component that often comes up as part of a checklist item towards the end of an audit. It's there because it needs to be done, as opposed to it's there because people believe in the intrinsic value of the data. So what we think is that the data, the analysis, the collection of data and its use should be moved to the front of the audit, because that data can help drive everything else that needs to be done in the audit. And that's what we mean by when we say that data-driven engagement. Coupled with that, we see that the audit of the future will be much more infused with artificial intelligence. And artificial intelligence, lots of definitions. I know you heard one from Jeff yesterday. Artificial intelligence is a computer making a decision in a way that a person would. And we think that the audit of the future will be, we use the term infused, with much more of an AI focus, or an AI assistance from computers. So more and more, as data is being brought into the audit early on, that data can be used to augment the auditor's decision-making process and help make some of those decisions or suggestions on their behalf. So we see AI, or we predict AI will be used not just in the pure analysis of data, but eventually also in helping drive what data or what else needs to be done as part of the audit. And finally, particularly in, as you're all aware of the situation in the world today, but we see real-time collaboration being more and more important. And CaseWare, excuse me, CaseWare systems have always focused on collaboration as a key part of how the audit works. As we switch more to a cloud-enabled solution, or particularly with things like analytics AI, which is cloud-based analytics, we think that collaboration becomes even more of a key component, and being able to synchronize data with multiple other auditors, multiple audit team members, becomes a huge part of how an audit will be performed. So that will only become more of an item in the future. So the audit framework that we see of the future at a very high level, the audit now starts with collection of data. The data will drive the auditor's understanding of entity and will help the auditor set influencers. And we'll take a look at what influencers are in a moment. Some of the types of data that the auditor will be collecting at the very beginning of the audit, obviously GL and subledger transactions, trial balance. These are traditional pieces of data. They will be augmented. If you look down at the bottom of the screen, they'll be augmented in the future by things like third-party data. So public data sets or publicly previous filings, things that are available that can be brought in and enhance the audit with things like benchmarking information or historical information on the entity. So that data, once it's collected and normalized and available in a semantically meaningful way within the application, can help both drive what risks the entity are associated with the entity, as well as evidence that mitigates those risks or that those risks have been mitigated. So the data is both the source of the driver behind what needs to be audited, as well as the proof that the audit has been done. And this can drive additional procedures. It can drive a requirement for evidence that is not within the data set. So it can tell you that you need to go find something else. Or it can drive the fact that that data is not available. So you might see a risk that has not been mitigated. But either way, when you have a good source of data that's understood, it drives to some self-documentation. So we'll see how some of that, we can provide some documentation automatically as well. And these become the deliverables that go back to the client at the end of the audit. So the bottom of the screen I mentioned earlier contains some of the building blocks that we see being part of a technical solution for the audit of the future. So the two we'll really be talking about today are analytics and AI. Two other foundational pieces that come up again and again when you talk about the audit of the future are third-party data. I mentioned there's other data sources out there. So the first and second party being the auditor and the auditee, the audit entity. Third-party data being things like bank confirmations, customer receipts, all sorts of other data that's available. Some of it public sources, some not, but things that you can bring in to validate the data that you already have or to make predictions of what might happen, et cetera, et cetera. The other interesting source that is definitely worthy of an entire day's worth of meetings on its own, but we'll skip for today, is blockchain. And blockchain we see being as a potential part of the audit in two areas. First is more and more information, particularly financial records, gets written to various blockchains, it becomes a source of data. So we need to learn techniques or build techniques to mine different blockchains for the information they contain, because it becomes a data source that can be used in the audit. The second potential use of blockchain, particularly from a CaseWare and idea perspective, this is particularly interesting, is you can use a blockchain to document your audit, to log your actions taken during an audit. It's a particularly robust mechanism for creating a file or a log of actions taken that is immutable itself. So as the auditor produces evidence or performs actions, a blockchain could be used as a way of recording those actions. And that now becomes an immutable record of every action that the auditor has taken. So blockchain is going to be something that companies like IDEA will be looking at in the future as a foundational technology, both as a data source and as a method or a tool used in performing audits. So today we'll be talking about our application Analytics AI. We like to say Analytics AI is for every engagement. So it brings analytics directly into the engagement. Analytics AI is built into a CaseWare workflow software called Client Engagements. So we have an online package. We'll take a quick look at it that allows you to build an online audit workflow, and we've built analytics directly into that. And it's got some artificial intelligence-based analysis, and our goal is to improve the efficiency, quality, and value of the audit by analyzing all data at once. So rather than perform sampling is a beautiful technique. Sampling it's mathematically amazing how well sampling works, but it's fundamentally only looks at pieces of the data. So we try and look at all the data at once. I'm getting a message, not able to hear anything. I think that might just be...
I think, Kevin, you are absolutely audible.
Okay, excellent, good, thank you for that. then I'm going to continue and allow people to sort out their issues. Thank you for the feedback. So we will be taking a look at how Analytics AI can improve the efficiency, quality, and value of the audit. And we will be looking at a couple of the features within the application. Key things, as you're all likely aware, it is impossible to perform any kind of meaningful analysis until you can get data into the system in a usable way. So we'll take a look at some of our tools for getting data into the system. We'll look at our data validation and completeness options. So once you get that data into the system, it's nice to know that you actually have all the data that you need. We'll take a look at how we can tailor transaction analysis to suit the data set that is available. And we'll take a look at some of our AI-based tests and discuss how our scoring model works as AI to provide feedback or provide information to the auditor on how transactions or the transaction set you're looking at looks and what the possible risk factors in it are. And that will blend into some of the powerful insights we can provide and give the auditor back information about what exactly their data set contains. And finally, and rather importantly, we'll take a look at some of the reports we can produce that help automate some of the documentation process. So with that, I'm going to segue into a demonstration of Analytics AI. We'll move there now. And you should still be able to see my screen, but we're now looking at a screen that says Kevin Entity on it. So this is the first screen that would be presented to a user after they've signed into our cloud platform. So as I mentioned, our cloud platform is really designed as a collaboration tool for audit teams. And without going into all the details of it, the first thing I'm going to do is select Analytics AI. So we have various applications that the auditor can use. Analytics AI as an application by itself is designed to guide an auditor through the process of collecting some data, validating that it's a complete data set, and then performing an analysis on it. What I'd like to keep in mind is that this workflow, or our tool rather, is designed as a audit workflow tool. So if you're familiar with CaseWare's working papers, a similar tool to that, but online. So while we have a very small analytics only workflow here, this tool is designed to be embedded inside a complete audit workflow. So what I'll do is start a new audit, and I'll give this one the name SAMA Demo. We're not going to carry forward any data, and we'll save this now. So I've started a new audit here, and what I will, with systems right now, instantiating an audit workflow. There's a couple of things to look at here. We use the year-end date to do some reconciliation work. My demo data set is for the year 2017, so that makes sense. And I'm going to save this off. So the first thing I'm presented with here is now I'm within the audit workflow or the analytics audit workflow. We have an option to perform a client query or a client inquiry. I won't go through this whole process now based on time constraints, but basically we can send a prepackaged note to a client contact to let them know that we want some data and we want the rest of this information as well. Now you could do this exact same process through email, but there's no tracking on it then. Email is not secure, and there are file size limits built into email that are, even in 2020, still fairly archaic. So the advantage of using a system like this is once you've pre-configured your client contact, you can send a note directly to them. They can come back to our portal, enter all this information, so it's available. This information is now available to the auditor for use in other workflow steps if it's required. But they can also upload their files directly to our system. So they're uploading a file directly over an SSL link, which means it's never over public servers. It's going from their computer to ours over a encrypted link. And there are no, or there are at least fewer file size restrictions than you'll find in email servers. So it makes life much more convenient. And finally, from a workflow perspective, this tracks the state of all your client requests. So whereas if you've sent a dozen emails to clients, you need to go through your email one by one to find where they are. If you're using a system like this, we can track all the requests. We understand the status of them. We understand when new updates have come through to them. So this in and of itself just makes life a little bit easier, or a lot easier, for an auditor. Pardon me. Going back to my workflow here, assuming that I've successfully received my files from my client, the first thing I can do is import a trial balance. So we have sources for importing a bunch of different data. We can import from CaseWare working papers directly, or we can import a trial balance from working papers directly. We can import a trial balance and transactions from many different desktop accounting sources. And we can import also from various online sources, two of which I have set up or possible in this particular demo site are QuickBooks and Xero. And we're continually building links to more online and desktop sources as well. However, for the purposes of the demo, I'm going to use what we find to be the most common data source, which is Excel or CSV, just to show you that it's a relatively painless process here. And give me just a second. I should have had this window open already, and I didn't. There we go. So I'm going to put my trial balance in place, and I can now map my trial balance. So I'll use my account number, and it's important that this account number is the same as the account number that's used in the transactions file that we'll take a look at in a minute, so that we can perform reconciliation against the two files and make sure that they match each other. I'm going to import my current year amount, and I'm going to import my account name for each file. Scroll down, and I can import the file. We'll take a look. Here's the transactions of the trial balance as imported into our system. It's warning me that one account has not automatically been mapped where excuse me, where possible, excuse me, where possible, we'll automatically map accounts to their expected financial groupings in our system. In this case, I leave one unmapped to give people an idea of what happens in that case. And I will add this to current liabilities, accounts payable, and that's done. So I no longer have an unmapped system. Next thing I can import is my transactions file. So I've imported the trial balance. Next step is to import a matching transactions file. I will do much the same thing, drag and drop it in. We will detect what type of file it is where possible. So in this case, we look in the file and find out it's a CSV file. We don't just look at the extension. Bring that in, and we've processed the file to what we'll call a staging area. So we have to tell the system that not only is this a CSV file, but we have to tell it what it contains. So going through this list very quickly, we've got a entry number. We'll skip that one. We'll just use this one actually. An entry number, a journal source, which is our document type. And we will tell the document type is general journal, et cetera, et cetera. What I will do is in this case, because I've got a saved one, I'm going to use a saved layout, just in the interest of time, rather than mapping every individual column here. We can save the layout types that we've loaded up. So if it's a file type that I've already loaded in the past, I can save off that definition and use it in the future. I can see that now my entire file is mapped and ready to go, and I can import that file. There we go, import has begun. I'm gonna close my import window, and my transactions should be loaded. So the next thing I can take a look at, there we go, transactions imported. I'm going to skip the data reliability checklist for just 1 second. I'll come back to it. And the next thing we'll take a look at is our data completeness check. So our data completeness check takes the transactions file and the trial balance and compares the two. So we look at everything using that financial statement grouping, or the grouping that we brought in or mapped to when we brought the trial balance in. We take a look at all the assets, liabilities, et cetera, and compare that with any carry forward and the transactions total, or the totals calculated from the transactions file, and try and determine if there's any difference between the two. So we note there are, a couple of rounding errors, and we see some profit arises. So there's no account for shareholders' equity, but it matches our amount up here. So we're all good here. If I could spell properly, label that as profit. And then being that we are accounting workflow software, should I choose to, I can sign this off both as a preparer and a reviewer if I have permission for both. So we're ready to perform our analytics now. You'll note that because I signed it off, I get a green check mark here. Should I choose to, I can go and answer my data reliability checklist now as well. So again, as this is audit workflow software, there are a fair amount of checklists in it, or you have the option to add a fair amount of checklists. And in this case, we have one to validate that it's complete data set as well. Again, in the interest of time, I won't fill out the whole thing, but the answer is I can come through, do the accumulators match, et cetera, et cetera, et cetera. And then I could sign off on that as well. More interesting than that for the purposes of today is this idea of influencers. So Transactions analysis is fairly mathematically rigid. A high amount is a high amount is a high amount. There's relatively no room for opinion in it. But what we can do is let the auditor inform the system of what they know about the entity. So for example, a well-established company may choose to, or their auditors or their accountants may choose to completely legally make decisions when performing discretionary accruals that will tend towards minimizing declared revenue so they can minimize the amount of tax they have to pay. Conversely, a startup might go the exact opposite route, whereas where they may want to maximize the any discretionary accruals and revenue so that they can appear a bit bigger than they are and impress investors. So we have the ability to take any account and say, you know what, if we do see any risk in the sales account, please immediately multiply that risk by 25%. And this is a tool we're still we're building and we're enhancing. Will eventually be driven by a wizard type approach. For now, it applies influence to these different accounts as we in a way that lets the auditor set them up. So I've added 25% influence to any transactions that have the sales account in them. And finally, we'll get to the risk analysis. So while we have been talking, after I loaded the transactions, while we were doing the data completeness check and setting up our influencers, the system was actually running the analytics in the background. So one of the things we feel is that because we're trying to run things automatically and because we're trying to run analytics based on default parameters, there's no reason to make the auditor wait, or no reason to wait and have them manually kick off the analytics process. We can start that and have it going for them so the results are ready when they get here. And what they're taking a look at then, in the top left, we see a risk summary. So the risk summary is a breakdown of all the transactions, which ones did we see with zero risk, which ones with relatively low risk, medium risk, and high risk. Everything on this screen, or almost everything on the screen, is clickable. So if I want to drill in and see only the high risk transactions, I can do that. We'll take a look at how we look at the transactions in just 1 second. I'll work my way down the screen. Up in the top right, we can see the highest risk exceptions. So we've decided, or feedback has been that by dollar value, the dollar value of transactions flagged by that exception is a useful piece of feedback. So in this case, we can see that a total, and by value of transaction, that's the sum of the debits. So the transactions technically work out to zero, but we sum the debits to give an idea of the magnitude of the transaction. So we can see that a total of 747 transactions totaling about $1.5 million have been flagged by Benford's Law, or a 2-digit Benford's Law detector. Now, one thing we have intentionally not done is, in this case, it looks like, based on my experience as an auditor and an analyst, I know that if 747 out of 888 transactions are flagged, that probably means Benford's Law doesn't apply here. For the moment, we have not automatically coded any system to turn off particular rules like this. The reason for that is we want the auditor involved in that, at that level of decision making. We don't want to be a black box as far as making that kind of decision about what tests are run or not. So I'll show you how we can turn the test off very easily in a second. Similarly, with rounded amounts, we see a total of 219 transactions worth about $1 million have been flagged by our rounded amounts detector. And again, 219 out of 888 is probably a fairly large number of transactions. So I'll show you how we can focus that a little bit and tailor the parameters that we use a little more closely to the values that are in the system. The other two tests we can see here, the other two highest risk tests we can see are high amounts, which makes sense. It's looking for the highest amount, so it's going to have some of the highest values in it, and unusual users. So in 62 cases, we have users that aren't frequently working in a particular journal in that journal. Moving down the screen a bit, and again, any test on here is clickable, so we can see more results or the individual transactions that make up that test. Moving down the screen a little bit, we can see who the highest risk users in this data set are. So we break down the users by the dollar value of transactions and then the individual risk values of those transactions. So you can see a little bit of a breakdown of how risk is spread out by users, and similarly how risk is spread out by journals. So you can see in this case, the general journal seems to have the lion's share of the high risk, and the total value of the general journal labeled entries is a little under $800,000. Moving down a little further, we have a time series risk to value of transactions chart. And what this is a technique called contribution ratio analysis, where we look at the percentage or the overall amount of risk compared to the amount of a risk we found in the transaction set compared to the dollar value of the transaction set for a given month. And this gives you a really neat tool for being able to compare risk and dollar value contributed by that month graphically. So we can see July has a higher risk bar than it has a dollar value bar, which means something interesting may have happened there. Rather, July has a almost as high a dollar value bar as a risk bar, whereas March, for example, is a much higher risk bar than it does dollar value bar, meaning that something interesting may have happened in March. So this is the one screen that's not yet clickable. It will be soon. And finally, we get down to the transaction details. So what we're looking at here is a breakdown. This top transaction, or this top line, represents the highest risk transaction we found in the data set. So the red background indicates it's high risk. The 170 there is its risk score as we've calculated it. This is transaction number 363, performed by Queenie Brunt on July 14th, 2017, and we totaled it for $100,000. So if we look at the details, we can see the individual lines that make up the transaction, and we see which tests flagged for this transaction overall. So we see the specific keywords. We have a specific keywords detector that flagged for these two lines. They both contain the word estimate, which is not something we want to see. We see that it has the same user, Queenie Brunt, here entering and approving the transaction, which is a no-no as far as financial workflow goes. It's missing descriptions on these two lines here. So that's what that NA means. It's not available. Every line in this transaction is a rounded amount. Every line in this transaction is one of the highest amounts in the data set. And these two lines in particular are violators of Benford's Law. So on that note, we made a comment, or I made a comment earlier, that Benford's Law doesn't really seem to apply to this data set. So we can go into our configuration and we can turn off the Benford's Law test, and we can take that rounded amounts test. And we see that in our data set, this is our breakdown of how rounding looks in this set. Our default is to look for rounding to the nearest 100. We can change that to looking for rounding to the nearest 1,000 to make it a little more appropriate here. The other thing I'll do is very briefly on the screen, in the interest of keeping a relatively sane time today, we have 23 tests in the system, 15 of which run automatically, and these are what we call heuristic tests. These are based on easy to explain, easy to understand rules. So things that end in 999, high amounts, complex account combinations. All of these tests that have been flagged are tests that you can explain to a client very easily. We also have 8 artificial intelligence outlier analysis tests that are much more difficult to explain. So I'll turn on the one that we usually use as an example, the isolation forest outlier detector. Isolation forest outlier analysis is a technique that looks at each individual entry in the system and then builds what mathematicians or computer scientists call a decision tree to make a series of decisions to determine how difficult it is to isolate this individual value. So the longer, the bigger the decision tree here is, the more difficult it is to isolate this value, so the more likely it is that it's in a cluster. If it's very easy to isolate a value, then it's more likely an outlier. So because it builds one of these trees or multiple trees for every item in the list, it builds a forest of these trees, and hence the mathematicians who designed the algorithm named it the isolation forest outlier detector, because they have an interesting sense of humor. So I've turned this detector on, I've turned the other 2 tests off or tweaked them, and I'll go back and run our tests again. And we'll go back and take a look at our results. These tests run fairly quickly, and we now see that the highest risk exception is our isolation forest outlier detector, followed now by high amounts, unusual users, and rounded amounts. And if we take a look at our transaction number 363 again, same transaction, we no longer see Benford's Law showing up because we turned it off. Rounded amounts, we'll take just a quick look at this transaction here. This one still shows rounded amounts for anything rounded to 10,000 and anything rounded to 1,000, but things rounded to 100 no longer show up as risky. And that's because we tweaked the value on that test. And finally, our isolation forest outlier detector flags every line in this transaction. And that does make some mathematical sense in that high amounts are pretty much by definition an outlier. So a well-designed outlier detector, as isolation forest is, will pick up the high amounts. So I finished my analysis. I've decided that my parameters make sense. What can I do now? There's a couple of things. I've got all sorts of different filters in the system. If I want to take a look at one particular journal or account, I can do that both by drilling down or by my document type or journal source over on the left side, or by using the filters. I can then take a look at, there's a couple of ways I can now get information out of the system. So I can take a look at an analysis summary, which is a document that we generate, which I will generate right now. And then I can take a look at some results CSVs as well. I won't generate those, we've all seen CSVs before, but basically I have the option to pull any of the information out of the system with its risk analysis associated with it as well. And that means that if I want to use something like IDEA to take these risk scores and join in through the interface that we have, I could download a CSV to do that. Or if I simply want transactions. If I filtered this screen, when I perform my downloads, the CSVs that I download will be reflective of filters I've applied. So if I only want my highest risk transactions, I can filter to those and export them. So what we'll do to take a look at that analysis summary down here, I'm going to go back in here and I can show you just another last tool that we have. As part of a workflow, I can upload a PDF. So I can upload various types of file, one of which is PDF. And I will upload my Kevin Entity Analytics AI summary for the fiscal year that ended 2017-12/31. If I open that up, we'll see that this is the SAMA demo I did with a total of 888 transactions, which is what we had in our analysis. And it was performed by Kevin, generated from Analytics AI. A couple of things to note here. We've generated, or we've included our overall summary graph of where we see risk and dollar value for the fiscal year, as well as a breakdown of the individual line items that make up that graph. I've then included a summary of all the analytics we actually performed as well. So if we've turned a test off, it won't show up here. So there's no excess or confusing information clogging up the summary. But we've provided enough information between these two that you can regenerate or get another copy of the transactions file and regenerate this analysis if need be. So we include all the parameters that we use, the monetary value of transactions that we flagged, and the total transaction count that we flagged by those tests. So all the information you need to perform this analysis or to record it for your audit is here. Finally, we also include a list of what influencers were applied. I'll show you that real quick. That influencer we applied, that 25% on sales. Well, this transaction had a sales account in it, so we've applied a 25% influencer, and then the score up here will contain a 25% bump because of that influencer. So again, it's a way of flagging that sales account as something that we need to pay extra special attention to. So that's the demo of Analytics AI for the day. I've taken you through why we built it, who it's designed for, what we see the audit of the future as, and a little bit of how to use the tool. I'd like to take some questions now if there's any in the group. So I will pop open the GoToMeeting again if I can do that. And I'll open up the floor, or ask that Manish open up the floor so we can have some questions. Thank you.
Yeah. So do you all have any questions? I don't see anyone which has come up till now.
I didn't see any either.
Can I ask a question, Kevin?
I'd be more than happy to, yeah.
We saw outlier test in IDEA yesterday.
Yep.
And we have seen an outlier test here using machine learning, right?
Yep.
Now, what's the difference between the two? Why do we need to do it here, or why do we need to do it in IDEA? And what's the difference?
So they're actually similar but not identical tests implemented between the two. The tests we've picked online, we've used some packages from Python called Pyod and Scikit. One of our goals when we built the online system was to make it extremely easy to use. So IDEA is a very powerful tool, but it tends to have a bit of a steep learning curve on it. B, we wanted to have a variety of easy to explain tests. So the reason we picked open source tests for Analytics AI is so that if a firm wants to see the code under the tests, they have the option to do that. So as far as the difference in implementation between the two, I think we both use one of the same tests. They use a collection in IDEA. We use a slightly different collection here, but our focus was to find stuff that we will freely share.
Right. Thank you.
No worries.
Kevin,
yeah. Jairam.
Kevin, there's a question from Rajesh. He would like to know, what are the prerequisites for successful AI development?
That's a very big question, but I would answer that there's the prerequisites for successful AI development are, as a product manager, knowing what your goal is before you start or AI development, as well as working with both industry experts and statistical or computer experts. So you have two basic problems when doing any kind of AI. So focus on outlier analysis, or the type of stuff we've been working on here. You need to make sure that what your AI finds is statistically significant, which is what it's designed to do, but it also has to be practically significant. So statistically significant means that there's a mathematically valid or a mathematically interesting difference between two things, or at a certain p-value, right? So there is a better than what the p-value is chance that the thing did not happen randomly, or a random chance would not have created the same thing. That's statistical significance. And that's what computers will really find. What you then need is to work with industry experts to make sure that that statistical event actually has some practical value to it. So being able to tell, just looking at my wall in front of me, being able to distinguish between two slightly different shades of blue might be of interesting to statistical significance, but of no practical value. Being able to distinguish between the blue wall and the beige wall beside it would be a practical value. So in outlier analysis for financial statement analysis, statistical value would be that, there's a mathematical difference between some of the values in the list. Practical value would be, is there actually a material misstatement there? So what we're working on now is some of the heuristic tests we have all been proven to help find or help point people in the direction of material misstatement. What we're working with some of the governing bodies now on is making sure that the outlier analysis tests also have value in finding material misstatement. Everybody has sort of a general feeling that yes, they probably do, but it's now up to us to work with some of these guys to prove that that's the case. So it's understanding what your goal is and understanding the difference between statistical and practical significance to achieve that goal. Off the top of my head.
Thank you, Kevin. Yeah, thank you, Kevin. Are there any other questions from the group participants?
Last question, what is the name of the product demonstrated? The name is Analytics AI. So I'll blend it together. Somewhere in here, I have my demo deck, Analytics AI, like that.
Different from IDEA. So it's not a feature of IDEA 11 that we are looking at today. We are looking at a different solution, right?
That's correct. So IDEA 11 has been released. This is built based on another technology stack that is purely cloud. So this is built in CaseWare's, based on CaseWare's cloud offering stack. So IDEA is a subsidiary of the parent company, CaseWare International.
There's one other question that's come up. Does it work on only day books and sales, or it also works on inventory records and other data sets?
So right now our analysis is focused on journal entry testing. We are launching a new feature over the next couple of months wherein our distributor network and ourselves will be able to add more tests through what are called Jupyter notebooks. So as we launch that feature, we'll be adding more tests to focus on inventory records, general or sub-ledgers, smaller areas of the general ledger, that type of thing. So for the moment, yes, we're focused on daybooks and sales, as you call them. Inventory records will be coming. All right. I'm not sure if that wraps it up. By all means, feel free to contact me through SAM Audit. If you have more questions, I work with them on a regular basis, and I really appreciate the chance to speak with everyone today. Manish, thank you for the introduction, setting things up. As I said, thank you all for listening, and I thank SAM Audit for giving me the chance to speak.
Thanks, Kevin. Thanks. I'm sure that it was a interesting introduction to analytics on, and I'm sure that people would have a lot more questions as one starts thinking about this element of analytics too. Thank you very much. Thank you everyone for joining in for the session today. We really appreciate your taking the time out and being here today. Thank you.
Appreciate it. Thank you all. Bye.
Thanks.
Stay safe.